Let's talk about the different identification tests for the various groups of organic chemistry. Let's say we have an alkyne. How do we identify an alkyne? One way of doing so is by adding dilute sulfuric acid with mercuric ions with mercuric ions under 60 degrees Celsius, in which case the alkyne will be converted into a carbonyl compound. And carbonyl compounds, at this time I have taken a ketone. If we add 2,4-dinitrophenyl hydrazine, 2,4-DNP, it will form a red-orange color precipitate, and that's one way of identifying an alkyne. Another way of doing so is by adding sodium, and we will get this group, triple bond C minus plus Na, and the evolution of hydrogen. These reactions, however, these last three ones are unique for terminal alkynes only. This can be a non-terminal alkyne as well. This thing, AgNH2 twice, or NH3/AgNO3 ammonical silver nitrate, is what you would call tolerance reagent. By adding tolerance reagent to an alkyne group, we will get a violet color precipitate, triple bond C Ag. While if we can do so with ammonical copper chloride as well, ammonical NH3/Cu2Cl2, in which case it will form a red-brown precipitate, which is basically triple bond C Cu. Now let's go on to identifying phenol. I simplified the benzene group into this circle because it was convenient for me at that time, but don't do this. It's for the sake of the summary also. Phenol can decolorize acidic permanganate. It can also react with sodium to evolve hydrogen gas. It can react with ammonia. It can react with sodium hydroxide to decrease the temperature of the reaction mixture. It can react with neutral ferric chloride to form a purple color solution, which a purple color it disappears when shaking, however. Phenol also reacts with bromine and bromine/Fe, basically bromine and a Lewis acid catalyst, to form a yellow-white color precipitate, which basically is tribromophenol. Yeah, I'll discuss it later. Oh, by the way, alkenes and alkynes, they can both decolorize the red-brown color bromine CCl4. It can decolorize acidic permanganate, and it can decolorize basic permanganate as well. This is aniline. Aniline can react with HNO2 nitrous acid above 10 Celsius to form phenol and evolve nitrogen. The evolving nitrogen part is what makes this identification possible. We can also use Br2Fe and observe a white yellow precipitate with aniline as well. Another thing we can do with aniline is we can react it with nitrous acid below 10 degrees Celsius to form what you would call a benzene diazonium salt, and we can produce acidides with it. Basically, if we were to add phenol, we get an orange azodide, and if we add beta naphthol, we will get a red azodide, and that is a great way of identifying aniline indirectly. Oh yeah, by the way, the diazonium salt, if we were to add lead acetate or silver nitrate, we will observe precipitates because of it reacts with it borrows this Cl minus group. And basically, by identifying the diazonium salt produced, we can identify the presence of aniline. Benzoic acids now. Benzoic acids can produce carbon dioxide from carbonate groups and bicarbonate groups, and it can react with sodium to evolve hydrogen as well. Like a real acid, it can react with sodium hydroxide and undergo a neutralization reaction which decreases the temperature of the reaction mixture. And by adding neutral ferric chloride, just like with phenol, it produces a purple color. But that purple color, it disappears if we were to add dilute acid and shake it. No, actually it doesn't disappear. That happens in phenol. In benzoic acid, the purple color remains even when we add dilute acid and shake it. Now let's talk about alcohols. There are primary, secondary and tertiary alcohols. And this is how we differentiate it. We can't do that with sodium because with sodium all alcohols produce hydrogen. Only primary and secondary alcohols decolorize acidic permanganate because they can oxidize into something basically, but tertiary alcohols cannot oxidize into anything, so it won't decolorize acidic permanganate. But the best way of differentiating them is by the Lucas test, and we add what we call the Lucas reagent, which is zinc chloride concentrated hydrochloric acid. It takes a long time for primary alcohols to form the white color turbidity, while it forms in 2 to 3 minutes, a moderate time for secondary alcohols, while tertiary alcohols form a quick turbidity with the Lucas reagent. This is the carbonyl group compounds. We got a aldehyde, we got a ketone, and exceptionally we have formic acid over here because it has a partial aldehyde group as well. Basically, if we were to compare aldehydes and ketones, the only test that they both will pass is the Brady's reagent test. Brady's reagent, it is 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine is Brady's reagent. It forms a red-orange precipitate when a carbonyl compound is present. Yeah, you can see formic acid. It doesn't give a test with. It doesn't show a positive test with Brady's reagent, which is why we can differentiate it. However, like ketones cannot decolorize acidic permanganate, neither show a precipitate with Tollens reagent and Fehling's reagent. These are tests that are typically used for aldehydes, but formic acid can also show these tests because of a partial aldehyde group. You can distinguish between those two, between aldehydes and formic acid, using the Brady's reagent. Now, amides. There are primary amides, secondary amides, and tertiary amides. You can differentiate them by adding hypochlorous acid, by adding nitrous acid. If we were to add nitrous acid into primary amides, we will observe the formation of nitrogen gas. But if we were to do so with secondary amides, we will get a yellow oily liquid. If we do so with tertiary amides, we will get a clear solution. Yeah, that's pretty much it. It sums up quite a lot. Now, alkyl halides. We can easily identify alkyl halides by adding silver nitrate or lead acetate, as it will precipitate as halides. And we can add sodium hydroxide to acid halides, and it will form the respective organic acid and acid halide. No, sorry. Yes, hydrogen halide will be formed respectively. And this we can identify by adding sodium hydroxide, and this neutralization reaction is highly exothermic, and that is how we can indirectly identify the acid halides. And these are how we identify the different groups of organic chemistry.